Hi everyone, this is part 2 of section 1.4 and we're actually going to start off with a review problem from what we were doing last time. Here we have another function and we are told to approximate to the nearest hundredth the relative or absolute extrema of the following function. All right, so if we're given this function, we're first going to graph it. And I have that right here. And what we're going to do is, if we're looking for relative or absolute extrema, then we have to find the max or min. So I'm going to go to Menu, Analyze Graph. First, let's do the minimum. And that's right here. So lower bound, upper bound, right here. And you really want to get in the habit of having at least 3 decimal places here. All right. So here we're told to go to the nearest hundredth, which will be, negative 1.22, right? So what we're going to write here is, if it says the x values where they occur, we're going to say x equals negative 1.22 is our relative min, and we can just say min for that one. And then we're going to move on to the max. But for the max, now if it didn't specify to just give the x values, you would give both x and y, and you would say f of negative 1.22 is equal to negative 3.11. All right, let's go ahead and move on to the maximum. Here, I'm going to do Menu again, Analyze Graph, and I want to find the maximum this time here, and that's the maximum right there. Now, if your calculator isn't giving you enough decimal places, what you can do is bring your cursor so that it's hovering on top of that number. So you should get that hand button looking like that, right? The hand icon looking like that, and the value behind it kind of gets grayed out. And if you just press the plus or minus buttons, it will increase and decrease the number of decimal places. Okay, so here our maximum is at x equals 0.549. And then in function notation, it's f of 0.549. It equals to negative 0.369. Okay, let's move on to optimization. It just so happens I'm just teaching that same concept, optimization, in AP Calculus right now. So, just to give you a little bit of a context as far as like the relevance of that's concerned. Optimization is an application of mathematics where one searches for a maximum or a minimum quantity, right? So for example, what is the minimum amount of t-shirts I need to sell to maximize my profit, and so on and so forth. Okay, so take a look at this example. Advertisements for a new car claim that a tank of gas will take the driver and 3 passengers up to about 360 miles. So you go and you research on the internet and you find that the function for miles per tank of gas for that car is this function, where x is the speed of the car in miles per hour. And you want to know what speed optimizes the distance the car can travel on a tank of gas, and also how far will the car travel at that maximum speed, at that optimum speed. It is a good idea to get into the habit of either highlighting, underlining, or circling what you need to find, but pick one and be consistent. I chose to highlight this time, and if you choose to highlight, then in every single problem, try to highlight the information that you need to find. Okay, So we basically need, it says what speed optimizes the distance the car can travel. So basically what we need is the maximum distance the car will travel. So at what speed should I be driving so that I could get the most miles out of this one tank, right? So think about it. If you fill up your tank, and you're gonna start driving, each car has its own MPG values, right? And usually there is like city or highway and so on. So basically, and then you know that if you're driving too fast, or if you're like, starting and stopping too much, then your one tank of gas isn't gonna take you as far. So what is the optimal speed so you can maximize the amount of miles? All right. Well, okay, let's see what we've got here. We've got f of x, and this is the distance the car travels in miles. And we've got x, this is the speed in miles per hour. Okay, so what I'm going to do is I'm going to graph that function, and I'm going to find the maximum of that function. All right, so let's go ahead and graph it. All right, so take a look. I've got that function in my calculator, and when I press enter, I see nothing, right? Why? Because I don't have the proper viewing window for this. Okay, so if x represents the speed in miles per hour, let's go to menu, window zoom, window settings. Now we have to come up by sheer reasoning and logic, what is the best viewing window for this? If x min and max represent the minimum speed I can go and the maximum speed I can go, well, I can't go slower than 0 miles an hour, so x min is 0. And then how fast? Okay, how fast does an average car go? You know what? Let's be rebellious here. Let's just put 120 miles an hour. Okay, you're not going to go faster than that, I promise. Okay? All right, what about y? Y is the distance in miles you can go on a tank of gas. Well, obviously the minimum is 0. And what about the maximum? Are we in the 10s, the 50s, the thousands? What? Well, we have a number to go on, right? We're told that, on average, this goes about 360 miles. So why don't I press tab here and put in here 400 miles, okay? Enter. Oh, look at that. What a beautiful function. Now I see a maximum, okay? All right. So I'm going to go to menu, analyze graph, find the maximum, and that happens to be right there, 70, 362.5. So the maximum is at 70, 362.5. Now, remember we had said x is the speed in miles? That's the speed. And y, f of x, is the distance that the car goes. So the optimum speed is 70 miles per hour. If I'm driving at 70 miles an hour, at that speed, the car will travel a maximum distance of 362.5 miles on one tank of gas. Okay? Isn't that a fabulous way to apply max and min problems? Okay. Let's move on. Let's move on to average rate of change. Okay. On a scale of 1 to 10, how important is this? Well, just like everything else we learned in section 4, this also has a level of importance of about 10.5 on a scale of 1 to 10. Okay, and that goes for everything in this lesson. All right, so let's talk about average rate of change. First, let me ask you, in real life, what things do you know of that undergo change? If your answer is everything, you have won this game. Everything undergoes change. right? So, just think about that. How important is it then to find rate of change? Extremely important. Okay, average rate of change between any 2 points on a graph is the slope of the line through those 2 points. Okay, so suppose, right, we have some function, okay, and suppose this measures, I don't know, the position of a particle or of a person, all right? All right, so when you first checked in on this person, their position happened to be right there, right? Y equals, I don't know, 57 meters. And then when you checked on them again 10 seconds later, now their position is, I don't know, 40 meters away. Okay, so what is their average rate of change? To find the average rate of change, you draw a line between those 2 points. That line is called a secant line. This is important. Why is it called a secant line? Because that line intersects the function, the curve, at 2 points. That's why it's a secant line. When I find the slope of that red line, that's the rate of change of that function between those 2 points. Okay, how do you find slope, you ask? Well, you've been doing it since you were wee little, right? y2 minus y1 over x2 minus x1. So if this is y2, and if, well, we'll call that y1, sorry, I'll be consistent with the book. And if this is y2, right? So if this was x1, y1, and if this was x2, y2, well, what's our brand new notation for y? It's f of x. So instead of x, y, we call it x, f of x. So now, instead of y2 minus y1, can I just say f of x2 minus f of x1 over x2 minus x1? I can. It means the same, but it gives it a more sophisticated calculus spin to it, okay? And we are nothing if not sophisticated math students. So, in summary, the average rate of change on an interval from x1 to x2 is this, the slope of the secant line, which is given by that formula. Okay, let's go ahead and find one here. Find the average rate of change of each function on the given interval. This is my function, and the interval I'm given gives me my x values. So this is x1, x2. Okay. My formula, though, is f of x2 minus f of x1 over x2 minus x1. Okay, so what's f of x2? Well, I take minus 1 and I plug it into my formula. So f of x2 is equal to f of negative 1, right? And that's, when you plug negative 1 in there, you happen to get 0. And then f of x1 is f of negative 3. Okay? All right, so let me show you how we write it here in one step. So here we have f of x2 minus f of x1, and I say, okay, this is f of negative 1 minus f of negative 3 over negative 1 minus negative 3. That equals f of negative 1 is 0 minus f of negative 3 is negative 24 divided by 2. That's equal to 24 over 2, which is equal to 12. That's the average rate of change of that function. Okay, here we were given a function. What if you're not given a function? What if you're given the graph of the function? Well, it's actually a little bit easier if you're given the graph of the function, because now my interval is 2, 4. This is x1, bad habit, x1 and x2. Okay, the slope of the secant line is equal to f of x2 minus f of x1 over x2 minus x1. This time, when I need f of x2, I'm just going to extract it from the graph. F of x2 happens to be -2 minus f of x1 happens to be +2. So it's -2 over x2 minus x1. That's a lot of 2's over here, right? So that's -4 over 2, -2, right? So just to show you, rate of change can be positive or negative. And that does it for this section. Thank you so much.